for the inconvenience. So let me start again. Hi everyone, and welcome to this new session of Startup School. In today's session, we are going to discuss about generative AI, and I will try to approach the topic in a way to demystify it. At the same time, I will show you how to get started with Gen AI and large language models on Google Cloud. And at the end of the session, I hope you will know everything you need about how generative AI can help to accelerate and realize your startup ideas. I'm Ivan Nardini. I'm a customer engineer at Google Cloud specialized in AI ML, and I collaborate and enable developers and practitioners to build AI application and operationalize machine learning system. My goal is supporting companies or startups like you in turning AI into products for generating business value. And because behind each product, there is always an idea, let's start from the beginning. As a startuppers, you are here today because you have an idea and you want to realize it. Around you, everyone is talking about generative AI and large language models. Then you may wondering, should I consider generative AI? How generative AI and foundational model can help to speed up the process of realizing your startup idea? As you can imagine, there is no correct answer, but let's see what generative AI and foundational model are capable of. Starting from your startup idea, you may want to consider generative AI and foundational model in some particular scenarios. For example, you may want to consider generative AI for creating content such as product description starting from an image, or advertisement content starting from a copy. Another application of foundational models would be for summarizing knowledge, making it more accessible. For example, I personally have a customer who implement an insurance document Q&A application to answer specific questions about regulation. Finally, foundational model may help you automating time-consuming tasks. For example, you may use large language models to classify tickets and route them to the correct ticketing unit. Now, this is the theory, but what about the reality? If you bear with me, at the end of the session, I will show you Too Long, Don't Watch, a video summarization and Q&A application powered by foundational models on Google Cloud. But for now, let's assume that you have an idea that can get benefit from those Gen AI capabilities that I just showed. The first question you need to ask yourself is, should I build a task-specific model, or should I pick a foundational model to get access to those capabilities? If you decide to build your task-specific model, for sure, you will get a model who cites your requirements and it may achieve then better performances. But training the task-specific models require a lot of data, expertise, and considerable amount of resources, both for training and for serving it. On the other hand, if you choose a foundational model, you can get access to a multitask model which is fast to deploy and easy to use. And it can achieve good performances. But because it's trained on a massive amount of data, which are not related to the idea you are trying to build, they need to be adapted. And adapting foundational models typically requires less amount of data and resources compared to training a task-specific model. Because of that, you may want to consider choosing a foundational model to start building your startup idea. And as a Google Cloud, we provide several foundational models allowed to do that. For multiple modalities, including text, image, embeddings, audio, and code, Google Cloud provides several APIs. For example, with Palm's APIs, you get access to the Palm 2 family of models, which support the generation of text, embeddings, and code. Also, with Imagen API, you can create image, edit generated and existing images via text prompts, create captioning of images, and answering Q&A to analyze and explain your images. But this is not all. Last but not least, with the Speech API, you get access to Chirp, a 2 billion parameter speech foundational model, which allows you to build effective speech recognition application over several languages. All these models and these API that I just mentioned are all accessible via Vertex AI Model Garden. Vertex AI Model Garden provides a single environment to search, discover, and interact with those models, and in time, hundreds of open source and third-party models, as you can see here in the picture. Perfect. So now that you know how to get access to foundational models available on Google Cloud to realize your startup idea, the next question would be how I can use those foundational models to build an application that makes your idea real. Foundational models are in fact just a piece of what is needed. It is needed to build an AI application. If we look at the overall picture, these are some emerging concepts around foundational models that you might need to know if you want to build AI application powered by them. Foundational model, in fact, might be the core, but because they need to be adapted to your application, you need to know how to guide the model in generating desired responses. This is what we call, for example, prompt-based learning. And when passing detailed inputs to generate the desired output is not possible, you need also know how to tune those models and how to evaluate them. Another thing to keep in mind is that those models are large models. So you need to know how to deploy them in such a way that your user can rely on them. Now, covering all those topics in this session, it might require more than just 1 hour. That's why today I'm going to talk about prompt-based learning, model tuning, and model deployment. They represent the main concept you need to know to get started with foundational models on Google Cloud. Also, we are going to focus on large language models, which are foundational model works well with text data. But if you are interested to know more about all the other concepts you see in this picture, just let us know in the chat. With that being said, let's start with prompt-based learning. Prompt-based learning is this new approach to train large language models that uses prompt to guide the model in generating desired responses. The idea behind prompt-based learning is that LLMs need a prompt to generate a response. A prompt is just an input submitted to a language model to receive a response back. Prompts may include the task you're trying to achieve, some additional information, and some examples. And the prompt structures affect the generated responses. In fact, the way you decide to structure your prompts for generating the desired responses is what we call prompt design. Prompt design is the process of creating effective and engaging prompts to guide language models in generating desired responses. Let me give you an example. Imagine that you want to build a summarization application powered by large language model, which summarize information about Super Mario video games. As you can see in this slide, you may want to organize your request providing the summarization task first, so asking the model to summarize a particular text. Then all the information the model needs to generate the summary. In other words, you design a prompt in such a way that it has an instruction, which is the text in the prompt that you want the model to provide a response for. In this case, a task the model performs. This is an example of task input. And a context, which contains information model needs to generate the answer. As I mentioned, the way you design your prompt, it affects the capability of the model in generating the expected response. And because of that, there are many different techniques about how to design your prompt. Here you have some of them. For example, few-shot prompting is a prompt design technique where examples are provided in order to improve model performance in case of tasks such as text classification or sentiment analysis. So now you may wonder, okay, but which techniques I should use? The answer, as always, it depends. For example, few-shot promptings work with many simple tasks, but not with complex reasoning tasks. For complex reasoning tasks, you may want to consider chain-of-thought prompting, a technique which requires the model to show intermediate generative steps which result more effective with the complex reasoning tasks. Consider also that prompt-based learning is an evolving research field. Then the only way you have to master it is by experimentation. But this is not all. Also, the context of the prompt is relevant, and you can iterate on it for generating better results. Prompt engineering is the process of optimizing those prompts to improve the performance of large language model on a specific task. Let me give you another example and that shows prompt engineering in action. Imagine this time that you want to build a coding assistance application. Each time a developer calls the application, it generates the code he or she is asking for. Let's assume that your application uses just the prompt provided by the user to generate the answer. In this slide, you can see the result of the Palm API. As you can see, the Palm API automatically generates a Python function. The function does not have the doc string, and it is not in the PEP8 format. To improve the response, you may want to engineer a prompt that takes the user request and add some additional context information or contextual information. For example, you may want to specify that the function should be written in Python, it should be formatted according to PEP8 style guide, and it should provide documentation. As a result, you now have a well-documented and PEP8 formatted sum numbers function your developer can use. The important thing is that by enhancing your prompt, you now control that the foundational model generate a Python function according to your requirements. As you can imagine, you can iterate throughout this process till you get the result you expect. In other words, you can engineer your prompts. At this time, you may wonder how I can get throughout this iterative process, how I can try different prompts, evaluate the results, and store the one work best for a particular task. To support you in this process, as a Google Cloud, we provide Generative AI Studio, which is a sort of prompt playground. In Generative AI Studio, you can rapidly prototyping and testing generative AI models. You can test sample prompts, you can design your prompts, and customize foundational models to handle tasks that met your application needs. And as a result of all this prompt-based learning, you will be able to leverage multitask capabilities of large language models. So you will have different prompts to achieve different tasks with one unique model. You will be able to achieve a task with a limited amount of data. In fact, all you need to know is the information related to the task you are trying to achieve, the context, and maybe some examples you provide to the model. And also, you will make your model more robust by controlling the output, and at the same time, you will generalize it. At this point, you might think that prompt-based learning is all you need. The problem is that foundational models have several limits, and one important limit is the length of the input that you can process per each request. At the time I'm speaking, the text Python model, which is the Google Cloud foundational model optimized for a variety of natural language tasks, such as sentiment analysis, entity extraction, and content creation, has a max of 8,192 input tokens, where a token is a 4 or 5 character composition. Also, depending on the size of your model, another challenge is that prompt-based learning may not work as you expect. And finally, as you can imagine, the process of prompt-based learning, it implies operational overhead. In fact, it's still not clear today how to manage prompt versioning, testing, and more. That's why to overcome some of these challenges, model tuning has been introduced. So let's talk about model tuning. Model tuning, also called fine-tuning, is a supervised approach to improve a model performances on a specific task or help the model adhere to specific output requirements when instructions, so prompts, are not sufficient. With fine-tuning, you start from a large language model, You provide to the model with a training data set, and the training data set, as you can imagine, is the input, which contains many prompts response pairs. And as a result of the fine-tuning, you get a model which is able to mimic the desired behavior or task that you are trying to achieve. With respect to a traditional model tuning, what is interesting here is the training data set you have to provide. In fact, the training data set includes prompt response pair that are aligned with the task you want the model perform. Let me give you an example. Imagine that you want to build an application that automatically classifies some medical information. This is a perfect use case for model tuning because medical language is something niche and it is deviated from general language patterns. To fine-tune a large language model, in this case, you need a tuning dataset where each line contains a single tuning example. In this slide, you can see that each example is composed by an input text field that contains the prompt to the model. And in this case, we also have the instruction and the context, and an output text field that contains an example response that the model tuned is expected to produce. Once you get this data structure, the process of fine-tuning is quite similar to what you probably know. You start with the training tuning dataset you have just created. You extract the training prompt, in the previous example, the instruction and the context to classify the medical information. You pass it to the large language model. Then the large language model generates the completion or the response. In our example, it classifies the medical information that you pass. And then you use this completion within a loss function together with the original correct response to update your training, your gradients. And you keep going with the training process. As you can imagine, this process, you iterate over this process n times till the training ends. And finally, you can also use validation and test samples to calculate metrics and evaluate your fine-tuned model. Now, assuming that evaluation metrics values are good enough, you ended up with a fine-tuned model. So that's it. Now, probably some of you are asking themselves, this is it? It is just a matter of training dataset and some minor changes in the training process? The answer is no. And it's not just about the dataset that I just showed and the training process itself. It's also about the model, and in particular, its size, which depends on the type of model you choose. It can be billions of parameters or even more. In fact, training a model of such size implies that you need a large amount of computational resources, time, and consequently, it implies significant costs. Also, fine-tuning a large language model requires technical skill to avoid unexpected drops in model performances. And because of that, you might want to consider not fully fine-tune a large language models. In other words, what if you fine-tune just some parameters and keep the rest of the model as it is? Well, that's exactly the idea behind parameter-efficient fine-tuning. So let me introduce the concept. Parameter-efficient tuning, in short, PEFT, is a new approach to fine-tune large language model by training a small number of parameters for a new task. The idea here is quite simple. Rather than updates all model weights, you update only a few parameters. For example, some layers of the large language models, while the rest of them remain as it is. Now, there are several techniques on how to update those parameters. The one I just represented in this slide uses adapted layers. But the key thing here is that parameter-efficient fine-tuning provides several benefits. In general, it requires less resources, both in terms of computational resources and in terms of data. For niche tasks, you can get significant improvement in model performance by tuning the model in that way on a modest number of examples. And it implies a more flexible deployment because by changing only a few parameters, you can get several flavors of the same large language models maintaining its core capabilities. Now, although I explained this concept in a very simple way, it may look like a complex process for some of you. Then the question would be, should you take care of this complex process of fine-tuning? Again, the answer is no, at least on Google Cloud. Using the Google Cloud Console, APIs, or Vertex AI SDK for Python, you can quickly run a tuning job of a Palm text model. All you need to do is prepare your data as I just described, and then submit the tuning job. Then Vertex AI will take care of running a managed machine learning pipeline on Vertex AI Pipeline, which is the managed ML orchestration service on Google Cloud. And when the fine-tune finished, you will have your model automatically registered in the Vertex AI model registry, ready to be deployed. But let's think for a minute. Let's assume that you run your pipeline, it succeeds, and now you have your model registered in the model registry. And the model, as I just mentioned, is ready to be deployed. As you probably noticed, because we add additional parameters on top of the original large language model, the model is still a large model. Actually, it is even bigger than before, because you now have the size of the large language model plus the small amount of fine-tuned parameters that you just get from the fine-tuning job. As during training, the size of models affect what you need to do in order to deploy the model itself. Some of the main deployment challenges associated to a fine-tuned model are, for example, the storage I/O operation that are related to load, weights, and some components of the model itself. The time the models it takes to generate the completion or the prediction, and the budget of computing resources are needed to serve the model in a reliable way. These are just some of the challenges, as you can see in this slide, and there are more. Now, as you probably know, there are several model optimization techniques to deal with some of these challenges. The main model optimization techniques, for example, are distillation, quantization, and pruning. To give you an idea, distillation is a trust knowledge technique that can be used to reduce the size and the computational requirements of a model while preserving its accuracy. It is like a master teacher passing its knowledge to a young apprentice. Another technique that can solve the deployment challenges I just mentioned is quantization, which is a technique for reducing the precision of weights and activation of a model, which can lead to significant reduction in its size and computational requirements as well. In this case, it's just like when you switch watching a movie from high definition to a standard definition. Lastly, another technique you can use to deal with the deployment challenges I mentioned is pruning, which is a technique for removing unnecessary connection from a model, which can also lead to significant reduction in its size and computational requirements. It is like when you trim a tree. Now, apart those techniques, I personally found interesting the way we find out on serving large language model on Google Cloud. I found this way really interesting, actually. You can read more about it in the adoption of foundational model white paper we recently published. Here, just let me give you an high-level idea. When serving on Google Cloud, when you're going to serve a fine-tuned model, each time that a request is sent to an endpoint, the adapted layer are cached into memory to minimize the latency and sent to the foundational model services along the original request. So imagine that you want to, in our summarization application, you send the text that we want to summarize. Once the request is sent, the prediction is generated, and then it returns back to the user. The important thing to notice here is that the latency overhead of transferring the adaptive model is negligible compared to the inference of the large language model. Also, all flows respect several security conditions. And then as a Google Cloud, we really provide a solid deployment of your fine-tuned model. And again, all this without you need to take care of it. Why? Because all you need to do is jump in the Vertex AI model registry and deploy your model to an endpoint. And then after the deployment process ends, your fine-tuned model will be able to serve your generative AI application. With that, we are at the end of the session. So far, I described the theory that you need to know in order to use generative AI and foundational model in realizing your idea. But as I promised at the beginning of the session, I would like to show a generative AI application. So let me show you Too Long, Don't Watch. So this is a Too Long, Don't Watch application. The idea here is imagine that for some reason you skip watching an important event that you really like to watch. Would be great if you have like a technology that allows you to answer question and receive like concise information about the event that you just skip and you don't have time to watch again. So this is the idea behind Too Long, Don't Watch. Too Long, Don't Watch is a video summarization Q&A generative AI application, which again is powered by many foundational models on Google Cloud. Two of these foundational models are Palm API and Chirp, which I just mentioned in the presentation. So as you can see from the UI on the left, you have the video that basically is the video
everyone.
that
Welcome
we presented at the I/O. So now here the video is 15 minutes long. So probably, I don't have time to watch this video. And I just want to know what has been announced about maps, what is new about large language models. So what you can do, you can use this application to ask questions about the video. So for example, let's type what's new in maps and submit the request. As you can see, the application returns like a concise content which summarize what has been announced at the Google I/O 2023 about maps. So in this case, we announced that maps is expanding its immersive view technology to help to get where you want to go. And also the application is with this application, you can watch the moment this information or this announcement has been done.
At last year's I/O, we introduced Immersive View, which uses AI to create a high-fidelity representation of a place so you can experience it before you visit. Now we are...
So this is just an example of the application that you can build in order to, let's say, get benefits of the generative AI and large language models that I just discussed in our presentation. So back on the slides, as I mentioned, this is I just presented the Too Long, Don't Watch application, which again, it applies, it is powered by Palm API, Chirp speech to text, and Studio text to speech API. And it leverage these generative AI capabilities that are associated to our foundational models. So to conclude, the key takeaways of this session are quite simple. First, if you have an idea which requires to create or elaborate content, you should consider generative AI. Second, when possible, leverage foundational models, and don't forget that they are just a piece of what you need to realize your idea. Finally, on Google Cloud, you can find what you need to take the best out of foundational models for realizing your startup ideas. As a reminder, be sure don't skip the following Startup School session where Tristan and Mona they are gonna take a step further in your AI ML journey on Vertex AI to help you build, train, evaluate, deploy, and monitoring all these models to power your application. But for now, I hope you enjoyed the session and thank you for listening. So let's start. As I can see, I'm receiving. I have some questions to answer. So let me start answering those questions. The first question is how I can generate a 3D version of a real-world object using Google AI tools. Well, at that time, we don't provide an API that covers such capabilities. So this is something that it's not part of the image and API that I just mentioned. So another question is related to privacy consideration. Now, as I mentioned during the presentation, all the services, all the API has some privacy. They respect all our policies, so that are well documented in the API documentation. So I will, at the end of this session, I will share the link so you can figure it out if they respect the requirements that you have. Another question is how to get access to generative AI app builder, how to get approved for access. So there is to get access to generative AI app builder, there is a well-defined process. So what you can do is that, again, at the end of this session, I will share also the link to how that explain you, or that gives you the opportunity to get access to the generative AI app builder preview. How I train on. Okay, so another question is how I train AI about my business, so I don't have to explain what they're doing each time. I'm wondering if we can clarify a little bit this question, but as far as I understood, it's more related to how to like adopt AI in the business. Now, this is a really interesting question, and I personally found that I mean, in order to start adopting AI for business, it's important that all stakeholders are sit around the same table, and you start discussing about what you are trying to achieve. You evaluate which would be the benefits that you get from adopting AI in such a way that you can do like an in-depth analysis and try to understand if AI can solve or can helps you to enhance or to improve your business. So this is one thing that I would like to suggest. Do you think the context window limitation will be solved at some point? Okay, so about the, I'm just asking, I'm just reading questions. So another question is, do you think the context windows limitation will be solved at some point? Will it be a gradual solution or once and for all? I mean, as we are seeing, the context windows limitation is something under development. So probably we are going to see model with a large context window. But I mean, personally, I don't know if it's going to be like a gradual solution or something that is going to happen once and for all. Okay, so another question is, as a founder, when I should use BART. We see when I should look at Google Cloud Generative AI services. So as I discussed today, if you want to build an application for your startup, you may want to look at the Google Cloud Generative AI services, because this kind of services gives you access to generative AI capabilities in such a way that these models are enterprise ready. So guarantee you a set of they respect a set of requirements that probably you need in order to use these capabilities in your business. Can we test too long don't watch? I mean, this application has been built for showcasing. So what you can do is that you can try to use the API that I just discussed today to build such a similar application. And if you will do that, just feel free to reach out so we can discuss about how to do it. Do I need to train my own model or use a well-engineered prompt to make my large language model to be able to answer questions based on information contained with a PDF or XML file? Well, I can give you my personal answer here. So during the presentation, I mentioned about a use case that I personally had about a document Q&A application over in an insurance industry. So in that particular use case, a well-engineered prompt using a large language model was just perfect to address the use case that you mentioned. So to answer question about some content or information that was within PDF documents. So I will say that at least before training your own, before building your own model, at least try to use large language models to tackle this challenge. Okay, so it seems that we have no other questions. So again, I hope that you enjoyed the session, and thank you for the questions, and thank you for joining us today.